Rich, I appreciate the introduction. It's a pleasure to be here today. It's I believe, a very exciting time for the industry. It's a dynamic time. There's obviously a lot of changes, but I think the future is quite bright. I think most of you all know that our founder, Elon Musk, is a real believer in the importance of exploration and in particular going to Mars. He got into this business to a certain extent because he realized that, in particular started SpaceX because he realized that one of the biggest things holding us back is actually the transportation in getting there. He originally worked with Lance's company, Paragon, this is not as well known, on a project called Mars Oasis. This was when he had first sold PayPal, which, as you may know, was his previous company, and was really looking at doing a program with the founder of Paragon on Mars called the Oasis program to actually try and grow a plant and really excite people about what the future could be. What he found out, however, that one of the biggest challenges to doing anything on Mars is getting there and getting there economically. And Elon is just the kind of guy that when he sees a problem and no one else is solving it, he asks, well, why not? And he put together a group of advisors and ultimately founded SpaceX to solve the problem of economic space transportation. And I joined the company, Elon, about 7.5 years ago. My background, as Rich said, is more in satellite communications. And most of the panel were all about enabling exploration. I guess Tom's company, Space Adventures, is about enabling the specific participants, but most of us are working on the technologies to allow exploration. And then we don't know what sort of opportunities might be opened up, either business opportunities or larger sort of evolutionary philosophical sort of opportunities. But I'd like to just talk a little bit about what our contribution could be, again, is an enabler of space transportation. So with that, I'd like to show you just a very short 1.5-minute video, and then I'm going to just go through a few quick slides to talk about why I think it's a very exciting time for the industry, and talks first about a new product, a new launch vehicle that we announced just this week. So with that, we'll just show a quick video. If we can cue that up. It may sound a bit cliche, but we really do see it as our role to help enable the dreams of others, whether it business opportunities or just the exploration. Eventually, if one's dream is to go and explore Mars, well, that's what we are trying to do at SpaceX. Again, I'm just going to go through a little bit of a summary of some of the things that we've done and what we think we can do to open up the future opportunities. The focus of the panel, of course, is to talk about how the work that has been done in low Earth orbit and specifically on the International Space Station can open up future opportunities to go to Mars. This is just a little bit of a summary of our flight history to date, and I'd like to talk specifically about how what we're trying to do is evolve, start small with the Falcon 1 and evolve that technology into larger vehicles that ultimately will allow us to enable exploration of Mars. So we started with the Falcon 1 I think a lot of you all in the industry were following our success and rooting for us, which we certainly appreciate. And we did learn quite a lot on our first 2 flights. We did not reach orbit on those 2 flights, but that's a big part of this. And I think as we look to go forward and look to expand beyond low Earth orbit again and explore, that we have to understand that we have to be afraid to fail, or we can't be afraid to fail. And we have to be willing to fail. And I think that the early explorers, for example, Buzz Aldrin was certainly acknowledged that that it was a different era then. They were willing to risk failure and understood that along the way you're gonna actually have challenges, and there are gonna be some things that don't go exactly as planned, but that's part of the business, and that's something that I think we need to reintroduce back into the business. And that's one of the things that I think actually the COTS program, the Commercial Orbital Transportation Services program, has enabled. It has allowed the government to sort of step back, just set the standards, and then let private industry go and develop it. And what we do, if we have an engine failure while we're in development, that's our business. We work through it. We had launch failures early on, but when we got ready to do our first flight for NASA, we had worked out all those issues, and the flight was perfectly successful. So if we can go to the next slide, this is just to sort of show how we've incorporated a lot of the technologies and the learning from the Falcon 1 vehicle initially, where we tested out a lot of those systems, and we did have some challenges, and we did have some failures, but we were able to learn a lot and incorporate that. So with our Falcon 9 launch vehicle, which uses much of the same technology, a lot of the same avionics, the overall architecture of using 2 stages, the minimum number of stages that has been proven to allow you to get to orbit, and incorporate the same sort of structure with the same general engine technology, and in the case of the Falcon 9, actually the same engine, 9 of the Merlin 1s on the first stage, and then an upper vacuum version on the upper stage. And then the Falcon 9, which we just announced this week, which obviously we just talked about in the video, actually uses the same exact stage, 3 of them cross-strapped together in a configuration with the same 5-meter fairing that we're using on the existing Falcon 9. Talk a little bit about Dragon, which is the upper stage. We can go to the next slide, just to sort of talk about some of the things that we're doing on the ISS specifically. This was the vehicle that we developed for NASA, specifically for cargo resupply of the space station, which for a lot of you all know that we're coming up on the last space shuttle flight, and at that point, SpaceX and Orbital Sciences will have the main contracts to bring cargo to the International Space Station. And we were paid to modify a technology that we were already developing, but to develop it specifically to meet the unique requirements of NASA in bringing cargo to the International Space Station. The alternative is to pay our foreign partners to do so. We think that this has been a great investment. On our last flight, we became the first private company to successfully orbit and re-enter and recover the spacecraft. If we can go to the next slide, just talk a little bit about the details of the Dragon configuration and some of the things that it can enable. And this actually has a heat shield that you can see on the bottom. It's called Pika-X. It was a technology originally developed by NASA at NASA Ames, and we worked in partnership with them to develop a even more higher performing version called Pika-X. And this actually has a heat shield that could withstand actually a mission to Mars. And we have had some informal discussions with NASA about doing some early robotic type missions using Dragon. It's a very capable spacecraft, and combined with, if we go to the next slide, combined with the Falcon Heavy, it could be used for some early robotic precursors and some possibly even Mars sample return. And we could put about 400 kilograms on the surface of Mars, combining the existing Dragon and effectively the existing Falcon 9, but in a Falcon 9 Heavy configuration. So with that, I think in summary, it really is an exciting time for the space industry. I know a lot of people that work in the space industry, certainly in areas like Texas and Florida, are very concerned about the future because we're going through a major transition. It's a similar transition that we went through when we ended the Apollo program and had to transition into the space shuttle program. we don't underestimate how trying that must be for the people in the industry, but we think that the future is very bright. It sort of reminds me, as Rich said in the introduction, my background really was more in telecommunications, satellite communications, and the internet. And I remember very early when I started at the National Telecommunications and Information Administration, and my first project was to write, it was in 1993, write a research paper on the internet, because nobody in the government at that point really knew what the internet was. It was really just being used by, for the most part, higher education, and within DARPA, of course, who helped develop it. And at that time, the common refrain was, yeah, it seems like a pretty cool little tool, but it's not really clear how anyone can make money on it. And I was sitting there right in the middle of it, and even I couldn't figure out that, wow, even doing something as simple as registering computer.com, I could have made $5 million. But the reality is that obviously now the internet is incorporated into our lives, and there are a lot of people making money doing things that we could have never imagined. And I think that low Earth orbit initially offers potentially that same opportunity. We don't know for sure what those opportunities, what sort of discoveries might happen on the ISS. A lot of people have a lot of ideas, and hopefully at SpaceX we can, by bringing down the cost of access to space, we can enable those and ultimately leverage that experience and those opportunities to fund some things that can bring us all the way to Mars. So thank you very much. I appreciate your time.